Welcome back. So in this session, we are going to solve residues of the given functions at the specified points. So the first function is to find residue of the function f of z at its poles. And then the second problem is to find residue of the function f of z at the point z equals to ai. So the first step is always to find the poles of the function. So we say problem A, solution. We start with finding the poles by taking the denominator and then equating to 0, i.e. z minus 2, z minus 3 equals to 0, which implies z equals to 2 and z equals to 3 are the simple poles, or simply the poles of the function f of z given by z cubed over z minus 2, z minus 3. Now, by definition, residue at z equals to 2 will be given by a limit as z approaches 2 of z minus 2 multiplied by f of z, which will be limit as z approaches 2 z minus 2 times z cubed divided by z minus 2 multiplied by z minus 3. So that's the function f of z. And you see that this bracket and this bracket cancels out. So this will be limit as z approaches 2 of z cubed over z minus 3. Now, direct substitution will give us 2 cubed over 2 minus 3. 2 cubed is 8, 2 minus 3 is minus 1. So this will be minus 8. And then residue at z equals to 3 will be given by limit as z approaches 3, z minus 3 times f of z, which will be limit as z approaches 3, z minus 3, and then f of z is given by z cubed over z minus 2, or z minus 3 times z minus 2. So this bracket and this bracket cancels out. Then we remain with limit as z approaches 3 of z power 3, z minus 2. So direct substitution will give us 3 power 3, 3 minus 2, 3 power 3 is 27 over 1. So the answer will be 27. So those are the residues of the function at its poles. Now B, we have been given that f of z is z squared over z squared plus a squared. And then we have to find the residue at z equals to ai. even though they have already specified the pole of interest, the first step is always to find all the poles of the function. So you say solution, find the poles by taking the denominator, equating to 0 and solving. So i.e. z squared plus a squared equals to 0. And this can be written as z squared minus ai squared equals to 0, which is z minus ai times z plus ai equals to 0. And this gives you z equals to ai and z equals to minus ai are the simple poles of the function. Of the function. F of z given by z squared over z squared plus a squared. So that's the first step. Find the poles. And then because now the question is specific to which pole we have to consider, then we narrow down our calculation to that specified pole. So residue at z equals to ai by definition will be given by limit as z approaches ai of z minus ai you multiply by f of z. Now this will give us limit as z approaches ai, z minus ai, you multiply by z over, this can be written as a z minus ai, and then z plus ai, from which this bracket and this bracket cancels out. And so we'll be computing the limit as z approaches ai of the function z over z plus ai. Now by direct substitution, you'll have ai over ai plus ai, which will be ai over 2 ai, and this should be a half. So that's okay. So this was square. So this is z squared. Sorry. So this was a square. So square. So then now we have to square this. So squaring this will mean that we'll have, so this is square. So a squared times I squared. So this is -1. So I'll have negative a squared over 2ai. So which means a in the denominator cancels with one of the a here. So we'll have negative a over 2i. But then we can always multiply this by the conjugate of the I. So negative will be positive, and then I times negative I is 1. So we'll have a half a I as the residue of the given function at Z equals to AI. So therefore, the answer to the problem is a half AI, or a half, you can write this one as a half IA, because they have the same meaning. So that's how we solve that problem on how to find residues of the function. The first problem was at its poles, and then the second problem is at the point Z equals to AI. Thank you.